అడగరా సార్?
సరే.
థ్యాంక్ యూ సార్.
ఓకే అమ్మా. సో 3 type of ensembles, that is microtonal ensemble, canonical ensemble, grand canonical ensemble. This is 5 mark question, is a very very important question, compulsory question this one. So the behavior of the system, the order of the behavior of the system in the statistical mechanics, the concept of the ensembles, the essential, we have collection of the particles. In general, a single particle is referred to the system, and the collection of the particles as a whole and ensembles. The collection of large number of the assemblies is called the ensemble. Assemblies and is called the ensembles. The number of ensembles, the identical is feature is like volume, energy, temperature, etc. as called the elements. Which one? Volume, energy, temperature are called the elements. The elements difference is the state. The elements state the different, the coordinates and velocities. Different velocities and coordinates. That is definition of the value ensemble. That defined as the collection, defined as the collection of the very large number of ensembles, very large number of the ensembles, which are essentially independent of another, independent of one another, the identical as the for bulk properties. The bulk properties mean microtonal ensemble. Microtonal ensemble, that is we have to define in the microtonal ensemble. At the same time, the random collection is such that the system is the corresponding to the same microscopic bulk properties. Bulk properties, that is thermodynamic state of the different microstructure is called the ensembles according to the Gibbs formula. That is that depend on the Gibbs formula. Okay. So this is ensemble process. The radar and the this is ensemble system. The different type of ensemble. Next to the different type of the ensemble, we have 3 type of system is called the isolated the system, the closed isothermal system, and the open isothermal system. Okay. In the general, with 3 type of the system is called the ensemble. But one is the isolated system, closed isothermal system. Another one is open isothermal system. There is system is can be characterized by the different ensembles based on the exchange of energy and mass. Okay. The different ensembles based on the exchange of energy and mass. The three type of ensemble. One is microtonal ensemble. Second one is canonical ensemble. Third one is grand canonical ensemble. So first we discuss on the microtonal ensemble. Microtonal ensemble, the collection of essentially independent assemblies having same energy, volume and number of the system. Energy mean G, volume is V, number of system is capital N. That is 3 values. So all the system are of the same. The imagine these ensembles follow the individual assemblies are the separated by rigid, imperishable and well as insulated walls. So that is your diagram. Which one? Microtonal ensemble. So three values, so that the three E, V, and N remain the unaffected the presence of other system. So this is ensembles. First one is this one. Which one? Microcanonical ensemble. Microcanonical ensemble. So here this is the one. This is the ensemble EVN. EVN. E mean energy, V mean volume, N mean number of system. Okay. EVN. EVN. EVN is the transfer value. This is rigid well insulated walls. This is rigid well insulated wall. The insulated wall. The let us consider the isolated system. Isolated system of the which the total energy H of Q comma P E is equal to total which of the total energy H of Q comma P E is equal to which one? Q1 comma Q2 comma QI. This is a function is a frequency also QF comma into P1 comma P2 comma dash dash PF. That is the equation. So the lotus the face of the point, the equal energies in the space is called the energy surface of organic surface. So you consider a family of such that the energy surface constructed to the base space. So this is two neighboring the surface with energy G and to the surface neighboring surface with the energy E and E plus D E and E and E plus D E plus D. Each surface divide the space to into two parts. One which the higher energy, another one is lower energy. One is this is the two parts. One is higher energy, another one is lower energy. That's the divide in the two parts. So the space between them contains a number of base point contain a number of base points, the which are the constant, which are the constant. If you take the density, if the take the density has equal to 0, the value of energy except in the selected to narrow range, that is dou e, delta or dou e. Okay, the microcanonical ensemble is specified by the properties of rho e rho e is equal to is equal to e and e plus d. So that is equal to constant value also 0. So here rho e is equal to 0. This is the grand canonical ensemble. So this is properties also three type of properties. Rho is the function of energy. This is rho is function of energy, and the microcanonical ensembles the statistical equilibrium. Second one is, as it is statistical equilibrium, the average properties of such ensembles microcanonical will not vary in time and in time. The third one is the distribution of phase point is uniform. The distribution of phase point is uniform. That is the microcanonical properties. That is the properties. Okay. So next to canonical ensembles. Second one is canonical ensembles. Okay. So this is canonical ensembles also is the independent and assemblies, the independent assemblies having the same temperature, volume and number of identical particle. Temperature identical. So this is also three parts. That is how much? Temperature, volume, identical number of particles. That is n. Identical particle is n. V is volume. This is, we change the T, temperature. First one is what? Energy. Canonical ensemble lo microcanonical ensemble lo which one? Energy, volume and number of particles. Here canonical ensembles temperature, volume, identical particle. That is number of particle. Here is identical particle. That is n. Okay. So here T comma V comma n. So total is changed. This one T comma V comma n. Also T comma n V comma n. Also T comma V comma n. Okay. So this is canonical ensembles. So the temperature T, volume is V, and number of identical particle is N is called the canonical ensembles. So if the energy exchange that takes place, but the mass exchange does not take place. Okay, the energy exchange takes place, but the mass exchange does not take place. The ensemble is called the canonical ensemble. That is the ensemble. All of the ensembles are the thermal conduct. The thermal conduct with each other. With each other. The canonical ensemble can be imagined that the individual assemblies the separated by rigidity. So that is imperable the diathermal, but the diathermal walls, that is the diathermal walls, the energy exchange take place, the temperature the remain the constant, remain the constant. So the all the assemblies, the canonical ensemble can be referred to isothermal system, whereas energy exchange but the mass of the remain in the unchanged. That is also same the diathermal. Here is rigid wall, the insulated wall. There is what? Only one line there. So here is this one. This line what? Diathermal wall. This line diathermal wall. That's the concept of the canonical ensemble. So next, grand canonical ensemble. Third one is grand canonical. Third one is grand canonical ensemble. So it describes the, this is also same, the collection of independent assemblies each with the exchange of energy mass as well as mass take place is called the ground canonical ensemble. Grand canonical ensemble, the independent of assemblies is which exchange of energy as well as mass take place is called the grand canonical assemblies. Okay, so ensemble, it can be, it can be thought of as micro canonical ensemble, whereas both energy and mass exchange, both energy and mass exchange as the result of the exchange of number of particle, the result of the number of the particle, the chemical potential mu. Here is a chemical potential mu remain the constant, the addition to the temperature T, the temperature T, and the chemical potential mu is the, remains the constant. The following the represented the grand canonical ensemble. Ensemble. So which the individual assembles, individual assembles are separated by rigid, rigid, permeable, and diathermal walls. Permeable diathermal walls, that is T comma mu comma V. See also only you change this one. This is mu. It is also mu. Okay. So this is also diathermal wall. Same. This is also same diathermal wall. Mu is what? Mu is the chemical potential. Mu is chemical potential. This is temperature volume. Okay. There is the grand canonical ensembles. Grand canonical ensembles. The refer to the isothermal system. We now the both average energy and average number of the particle, the assembly grand canonical ensembles can be applied, the is the total is ensemble. Okay, This is 5 marks question is a very very important అండి. Okay, only 5 marks question is enough this one. Compulsory question అండి. So next uses of the ensemble, uses of the ensembles, uses of the ensembles. Uses of ensemble. This is also 5 marks only. This is also only 5 marks question. This is also important. Okay, no? So this is also that depending upon the three different situations, three ensembles are introduced the three ensembles, micro canonical and grand canonical are particular canonical and grand canonical are particularly useful of useful for two major regions. Two major regions. That one is first region. The first region 3 refer to corresponding to that is the thermal frequency occurring the situation. First one is 3 referral to the frequently occurring the situations isolated, closed isothermal and open isothermal. That is 3 used for isolated, closed isothermal and open isothermal. That is the first one. Second is the large assemblers. The large assemblies, the volume of thermodynamic quantities. The second one is large assemblies. The volume of thermodynamic quantities are not very sensitive to the not not quantities are not very sensitive to the method of measurement. Method of measurement. So the more details about the properties, more details of the properties is this ensemble and their relativity as thermodynamic quantities. Relativity and thermodynamic quantities will be dealt with the inclusion, inclusion the their comparison also be taken up to appropriate the covering all properties like probability distribution function, probability and distribution function and portion of function, that is etc. So you have the simple application of the ensemble, the derivative of the relation, that is rho of rho rho is equal to rho is equal to exponential 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 c minus e by k. So exponential e by k. The probability has the base point of the system, base point of the system S1, base point of the system S1. The lie in the element of the volume dV1, dV1 is the rho 1 E1 of dV1, the base point of the system, base point of the system system is equal to S1, the element of value dV1, the element of the value is dV1 is V1 is row of one of E1 dV1 dV1. So the similarly rho n rho n En of dVn, that is equal to, this is also same what, dVn. So the given the probability of space now given the probability of space is equal to Sn. The phase space of the system is the Sn. The value of elements, dVn, the value of the system, the value of the system dVn. So therefore, the probability the total ensembles lies in the value of elements, of dV is equal to the dV is the row of E dV is equal to row of E1 D1, row 2 of E2 dV2 dash 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 this one here dash dash row of n of En dVn. So that is equation 2. That is the equation 2. Change that one. So where is dV is equal to, here dV is equal to dV1 dV2 dash dash dVn. So the same row of E is equal to row of E is equal to row of row 1 of E1, row 2 of E2 dash dash row of n of En. So that is the equation. The written as also be the written as log log row of E is equal to summation is equal to summation n row of n and E of n dash dash of n E of n. The differentiating the equation, for example, this is equation 2.3. Here is equation 2.2. This is equation 2.2. First before question is this is first one. This is a 2.1. Okay, we change that one equation. So the difference. This is the you find out the differentiating. Okay, convert the differentiating. So first you calculate the differentiating. Differentiating 1 by rho into dou rho by dou e1 d e1 plus dou rho by dou e2 dou e2 dou e2 dou e2 plus d e2 d e2 plus dash is equal to which one? 1 by rho 1 dou rho 1 by dou e1 dou e1 into d e1 plus dou rho 2 by dou e2 d e2 plus dash 1 by rho n into dou rho n by dou en into d en dou en. That is the equation. The rho is depending on the dou is depending on the so far here the rho is depending. This is the rho is depending on e depending on e that is 1 by rho n into 1 by rho n into dou rho n by dou en dou rho n by dou en dou rho n by dou en that is dou rho n by dou en dou rho n by dou en is equal to 1 by rho n into rho delta rho 1 by delta e1 into de1 delta de1. So that is equal to minus 1 by k. K is safe. K is the say 1 by minus 1 by k is safe. So that value that substitute the row of expansion is the equation. First equation this one. Which one is the first equation here? Rho is equal to exponential of c minus e by k. C minus e by k. That is equation is safe. Okay, this one. So this one. So it calculates the row of exponential. You write that one. Row of exponential is the row 1 exponential of c1 minus e1 in by k by k. Okay, that is the c1 minus e1 by k. Here c1 and k are constant. Here c1 value and k value is the constant. c1 and k is constant. So remaining is k1 c1 and not e1. c1 and k is constant. So have the remaining the rho is equal to rho is equal to rho is equal to exponential of rho is equal to exponential of C1 plus C2 plus C3 dash dash Cn Cn minus 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 E1 plus E2 plus dash dash En by K. By is K. So here is C1 and K2 value, the constant is also remain the value exponential of the C1 term and E1 term, that is the K value. So C1 value is what? That is the C, actual value is the C, that is the exponential C1 plus C2 plus C3 plus dash Cn. The same time C is first equation you are observed exponential of C minus G by K, that is the formula. So that is the exponential this formula you are derivating C value C1 plus C2 plus C3 by C3 plus dash Cn value minus here E value. So E is C1 plus E2 plus dash dash En by K. K is the constant value. So that is the simplification. Finally, rho is equal to exponential of C minus E by K. That is the formula. This is uses of ensembles. This is also important question, that one. This is also only compulsory మీరు థియరీలో ఈ టైప్ ఆఫ్ ensembles, త్రీ టైప్ ఆఫ్ ensembles ఆర్ దిస్ వన్ కంపల్సరీ క్వశ్చన్ ఉంటుందమ్మా. యూజెస్ ఆఫ్ ensemble అని అడుగుతాడు ఎగ్జామ్లో, లేదంటే మీకు అది డిఫరెంట్ టైప్ ఆఫ్ ensemble దాని మాత్రం కంపల్సరీ 5 మార్క్స్ క్వశ్చన్ ఉంటుంది ఎగ్జామ్. ఓకేనా? సో నెక్స్ట్ వన్ density of distribution in space. This is also 5 marks question. This question you read, and all of you read, that one is enough. Okay, page number 15 14, page number 14. Page number 14 లో density of distribution in space, that question is sometimes it came your exam. Okay, that is not important question. So 2-3 times is came that question is exam. Okay, so that is also you are observed. Sometimes is read that one. Density of distribution in space. All of you read that question, amma. So next to Lewis theorem. This is very important question. It continuously came up the exam. This question, 10 marks question, is a very important question. Lewis theorem. Lewis theorem, compulsory question. This is very important question. 10 marks question. Okay. So this is the Lewis theorem. As the observe the dynamical state of the system, the dynamical state of the system, the dynamical state of the system, the instead of the time can be represented by the point of the space. Point of the space, that is instant of the time can be represented by the phase point, the point of space. So this point will not be stationary but will be moved along with the definite trajectory which is determined from the equation of motion. Equation of motion. So that is Hamiltonian equation of motion. Hamiltonian equation of the motion. So that is the Hamiltonian equation of motion. Uh, Qi is equal to Hamilton's Hamilton's equation of equation of motion motion Qi is equal to dou h by dou q dou pi comma pi equal to is equal to minus dou h by dou qi dou h by dou qi. This is formula is important and మన PhD entrance లో అడిగాడు ఈ క్వశ్చన్. This question Hamiltonian equation is a motion equation వాడతాను. ఈ two questions is the compulsory. మన PhD entrance లో అడిగాడు ఈ క్వశ్చన్. So that is q is equal to h of h is equal to h of q1 q2 dash dash q of q1 comma q2 comma dash dash qf into p1 comma p2 dash dash pf. So the consequently the density is rho of the system space that changed with the term which is given by dou rho by dou t. Dou rho by dou t is given point in the space given by the dou rho by dou t. Okay, dou rho by the dou t. Dou rho by the dou t. So is given of the space. So this is theorems is consist of two parts. This theorem is consist of the two theorems. One is the principle of conservation of density in space. The principle of conservation of density in space. Second one is the principle of conservation of extension in space. Extension in space. Theorem is two parts. First one is the principle of conservation of density in space. Density in space. Second one is the conservation of extension in space. Extension in space. So that is two parts. The density of space, the part of state conservation of density space, the rate of change deviation of phase point in the space is zero. Space is zero. That is space is zero. That is rho by rho by dou t is equal to zero. That is the this one density of phase space. Density of space. The representative points move the space like the in compressing the fluid. The in other words, the density of ground of space point the remain in the constant. Remain in the constant. That is first one. The second part, the conservation of second part, the conservation of extension in space. Extension in space. That is d into d into d into dou rho by dou t d into del rho by dt is equal to 0. This is which one? Extension in space. Extension extension of extension of space. Extension of space. This is the form. So the volume of the relevance the conservation of extension in space the d into del rho by dou t dt is equal to 0. The volume of disposal of the particular number of the phase point. Disposal of the particular number of phase point is conserved the throughout the space. The part is very useful of statistical. This part is the very useful of the statistical mechanics. So the first part of the dt, first this formula is dividing derivating this one. First part. So first part. So this one dou rho by dou t is equal to 0. Dou rho by dou t is equal to 0. So the consider any arbitrary hyper value. Consider any arbitrary hyper value. The d tar is equal to delta rho 1 delta q1 delta q2 comma delta qf delta qf qf into delta p1 comma delta p2 dash delta pf the pf. So the number of phase points in the volume elements, d tar change of the coordinates, and the number of system vary. The number of system vary with time. The rho is density of phase point. Rho is density of phase point. Rho is density of space points. Now the number of phase points in this volume element at any given instant, daily, any given instant, t is given by delta n is equal to rho delta theta is equal to rho delta q1 dash delta qf comma delta p1 dash delta pf. PF. So the time is dt. In the time dt, in the time is dt. Time is dt. The change in the number of base points, the change in the number of base point within the volume of phase space is given by rho dt rho dt d rho d q1 rho q1 dash rho d qf comma rho p1 dash delta q1 next to delta uh, pf. This is the p1 and pf. That is the change due to the number of system entering and leaving the value in dt. The dt. This is dt, volume of dt. The consider two phase of hypervalue normal to q axis with the coordinates q and q plus q and q axis q axis which one the coordinates q and q plus d q plus q and qi plus d qf. One. This is also one dqf. At the here q1 is component of f velocity. Component of velocity q1 is q1 is here q1 is what component of velocity of space p instant q I dash dash qf q I dash dash qf q I dash qf. This one next to p1 dash dash pf. Then the number of s space points is the enter in the first space in time dt. First space time is dt will be rho qy rho qi dt into rho qi dash dash rho delta q1 dash dash delta qf delta p1 and this sum this. So delta P1 dash dash delta PF. That is the space. The space row instead is to leaving the space QI plus delta TF. QI plus delta TF. This one. Delta TF. The value TF. The row into plus dou row by dou Q I is row into rho into plus dou rho by dou t into dqi dqi plus plus sorry dqi into qi plus dou uh, dou rho by dou qi by dou t dou t dou qi by see once again please rho plus dou rho by dou q1 into rho by dou q1 dou q1 plus into q1 dot plus dou q1 by dou q1 dou q1 dou q1 plus dou q1 dou q1 dou q1 dt q1 into dt 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 comma dot q1 q1 dot q1 dash dash dot qf comma dot q1 dash dash dot p dot p f dot p f f that is equation the because of density rho changes with the position and momentum coordinates rho changes the position of momentum coordinates position of is momentum coordinates position of momentum coordinates position and momentum coordinates and the opposite space opposite space opposite space coordinates q1 the change is t changes to the q1 plus delta q1 changes to q1 plus delta q1 the similarly velocities changes now the above the equation neglecting the the higher order terms we have the row row q1 dot row q1 place place row row into delta q q1 dot by delta q1 this term this equation you are right okay into place place q1 dot place q1 dot in comma delta rho by dot q1 delta rho by dot q1 delta rho by dot q1 comma delta q1 delta q1 delta q1 delta q1 delta q1 dt to q1 dt into delta q1 plus delta qf comma delta p1 just delta pf delta pf. So substituting the equation, this is substituting the equation 3 from 1, 3 for from 1. So this is your of the 3 from 1 equation. So on the equation 3, 3 from 1 equation, that is uh, you are observed the equation of my 3 from 1 equation, that one you are observed. So that is similarly you from 1 minus rho into dot q1 dot by dot q1 dot q1 dot q1 dot q1 by 2 plus 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 q1 dot dot do rho by dot dot q1 into 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 dt 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 this one, this equation you write this one. dt delta q1 delta q1 dash delta delta qf comma delta p1 comma delta uh, pf pf. So this is your right to equation, this equation you are the right. So similarly, for the P1 coordinates, first is P1 coordinates, next one is the Q1 coordinates. This is the Q1 coordinates. Similarly, second one is P1 coordinates. P1 coordinates, that is also minus rho into dou P1 dot by dou P1 plus P1 P1 dot P1 dot dou rho by dou P1 into dt 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 delta P1 delta Q1 dash dash delta QF comma delta P1 dash dash delta PF. So this is the T coordinates. T coordinates. This is the T coordinates. This one is Q coordinates. Q coordinates. So you change P coordinates and Q coordinates is you change this P values. This is your Q value totally. Here is P value. Okay, that is your change. So the net is the increase in time dt, increase in time dt, increase in time dt, increase in time dt. The number of system is the volume of space is given by space is given by d into delta n delta n by dt is equal to dt is equal sorry is equal to is given by d into delta n by dt, not is equal to this one. So this is equal to d into your derivation value is equal to d into delta n by dt dt is equal to summation of minus summation minus summation minus summation minus summation minus summation. You write this term, only this term, and this is the q term and p term, both equations, this one and this. Okay, is equal to is equal to is equal to is equal to rho of dot q1 dot by dot q1 1 dot q1 by dot p of 1 plus 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 dot p1 dot by dot p1 2 plus dou rho by dot q1 dou rho by dot q1 into q1 dot plus dou rho by dot p1 into p1 p1 into into dt dou q1 dash dash dot qf comma dou p1 dash dash dou pf. That is the equation. Okay, that is the equation you have to simplify this one. So q term and p term you are writing this. This is this value here. Next to p value plus this value, both equation q term and q coordinates and p coordinates. Next, this is the total you write the equation is this simplify the equation. That is the d into delta n by dt is equal to d into of delta n by dt is equal to minus summation of rho by rho into dot qi dot by qi 1 at q1 plus rho p1 dot by rho p1 at rho p1 plus that is the simplification is similarly. Okay, so next here q1 q1 d by delta n by dt is equal to delta rho by delta rho by dot dot dt 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 this value right on the value. So dt delta q1 dash dash delta qf comma delta p1 dash dash delta pf delta pf. So the simplification adds dou rho by dou rho by dou t is equal to minus of minus minus summation I is equal to 1 and y is equal to 1 and f f you write this equation. Which one? This. So equation rho into dot q1 dot by dot q1 dot Q1 plus dot P1 by this is the dot also dot dot P1 dot P1 dot P1. This is P1 also P1 there is also P1 here Q1 so Q1 okay so Q1 plus you write this equation this one similarly the total equation you write the summation value okay plus so you write that equation number dou rho by dou q1 into q1 dot plus dou p1 dot p by dou p1 is also dot into p1 we also dot on it. So that is the equation. The into P1 here this is dot this one is dot. So you write this also here P1. This is not. This is row. Here the row by dot Q1 into Q1 dot plus row by dot P1 into P1 dot. That is the equation. So the applying the Hamilton's equation, the Hamilton equation of the motion, Hamilton equation of the motion, the Qi Qi dot is equal to rho h by rho t rho h by rho h by rho p1 p pi pi and pi is equal to minus rho h by rho qi minus rho h by rho qi. Okay. So now we get summation I is equal to 1 and f summation I is equal to h is equal to h I is equal to 1 so f into dot q1 dot q1 qi dot by dot qi into uh, plus dot qi dot by dot q1 qi plus dot p1 dot by p1 dot by p1 p1 I not one I is equal to 0 is equal to 0 is equal to 0. So that is dou rho by dou t that is dou rho by dou t dou rho by do do t do t do t q comma t q comma t is equal to minus summation I is equal to 1 and f is equal to 1 and f dou rho by dou qi dou rho by dou qi dot dou qi into q1 qi dot plus dou rho by dou p1 pi into pi dot pi dot. The equation you are observed 3.19 equation 3.99 equation you are observed Lewis theorem that is known as this is Lewis theorem. This total equation this is Lewis theorem. So the further simplifying the d rho by dt is equal to d rho by dt plus dou rho by dot qi into qi dot plus 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 dou rho by dou p1 pi into pi dot pi dot pi dot and pi dot. So that is equal to also 0. That is also 0. Here that is d rho by dt is equal to 0. This is first part. This is number 2 part. So this is part is first part. The is proof of the required that is 0. Next to the according to the gives the principle of refer to principle of conservation of phase density any time the phase points are distributed uh, uniformly in the phase space the ever have uniform is the density is the density this is the part first part only. Next to second part the second part. So we have the second part what delta d by dt into into delta tar is equal to 0. That is the second part equation. D by dt into delta tar is equal to 0. Okay. So here delta n is equal to rho by uh, rho by delta tar or 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 d by d by d into delta n into delta n by dt 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 is equal to d, d rho by dt d rho by dt d rho by dt to dt d tar plus plus rho of d into delta tar by dt delta tar by dt. So since the number of phase points since the number of phase points since the number of phase points delta n is given, delta n is given, region of the space must the remain the remaining remaining the d of delta n of delta n by dt, delta n by dt is equal to 0. That is equal to 0. Same time that is that is d into d into rho of delta t torque, rho of delta t torque, by dt is equal to 0. dt is equal to 0. The second term is the second term is 0. So that is d into delta t torque is equal to delta t torque by dt is equal to 0. Okay, dt is equal to 0. So the principle of conservation of this is the principle of conservation, the principle of conservation of the extension, extension, extension. Which one? Extension in space. Extension of extension in space, space, space. Okay, space. So this is the two parts. The Lewis theorem means that the distribution of system, the states remaining the unchanged in time, one as the equilibrium situation, one as an equilibrium situation. In particular the specification, the specification such that of the micro canonical ensemble, that is that is rho is equal to constant, rho is equal to constant. Okay, that is rho is equal to constant. So that is, simplify the e not less than e not less than e plus delta e not less than is equal to 0, is equal to e not less than e plus delta e not less than is equal to 0, less than is equal to 0. The constant with the equilibrium situation in the quantum mechanics, equilibrium can be given in the terms, density matrix instead of the classical space density. Instead of the quantum mechanical and equilibrium situation can be given in the terms of density matrix, the instead of space space density, classical space so which will be taken off the equation. The totally, this is the Lewis theorem. Simplify the Lewis theorem. This is very very important question అండి. ఓకేనా? So next to uh, density of space in classical ensembles, density of space in classical ensemble. This is 5 marks question amma. So next to density of base points in classical ensemble. Density of base points, base points, base points in classical ensemble. In classical ensemble. Ensembles. This is 5 marks question only. Important. This is also important. You know? Density of base points in classical ensembles. This is also 5 marks question. This is important. So, according to the principle of conservation density, according to the principle of conservation of density, the base space, we get d rho by dt, d rho by dt is equal to 0. Is equal to 0. The density is constant. Constant is time. The density is constant. The time. Therefore the density must be function of constant. Must be function of constant of motion of phase space. Motion of phase space. The rho is equal to rho is equal to this is rho equal to which one? Rho into rho is equal to rho into e comma n. E comma n. Rho is equal to e comma n. G and n. Here G and n. G and n. The constant of motion of ensemble. The constant of motion of ensemble. Constant of motion for and the ensemble. Let us the ensemble consists of n. The consist of n system. The consist of ensemble consist of the system consist n small n the system s1 s1 system s1 system is equal to s1 dash dash sn. S1 dash dash Sn. The N1 and dash dash N1 dash dash N small n. N small n. Okay. So the point respectively, the points are respectively the probability that the base point of the ensemble in the elements of volume, the elements of the volume d dark. Volume d dark is given. D dark is given. D dark is given. Which one? Rho into e comma n. Aida 5 minutes. होता ना इधर होता ना डेढ़ हाँ O n d d dark d dark d dark is equal to rho 1 of v1 comma n1 v1 comma n1 d dark 1 d dark 1 comma rho 2 comma e2 n2 d dark t d dark 2 dash dash rho n of en comma En comma n d torque n d torque n d torque n that is d torque is equal to d torque 1 d torque 1 d torque 2 dash dash d torque n d torque n. Okay. So d torque n. That is the simplify the equation simplify the equation. Rho is equal to rho equal to rho 1 rho 2 dash dash rho n rho n. The equation log rho of e log rho of e log rho of e log rho of e comma n comma n rho of e comma n is equal to a plus a plus b e plus c n a plus b e plus c n. Here small small a b c that values constant of independent of e and n independent of sum or the constant of independent of G and N. The three cases are be considered three cases. This is three cases mean A, B, C. This is the three cases. You consider the value G and N are constant. First one, three considers three considers. First one is E and N constant. E and N constant. E and N constant. That is log rho is equal to that is log rho is equal to constant. Log rho is equal to constant. Constant. Next, second one is this is the space point moves the hyper value. Hyper value is the such that the density of space point, the volume remain the constant, which is the case of microcanonical ensemble, which is case of microcanonical ensembles. Okay. So next one, the second one, n is constant. Second one is n is constant. Second one, n is constant. N is constant. So which one is the n is the constant? This is also same. First one is e and n is the constant. Here is n is constant. Log rho log rho is equal to be plus constant. Be plus constant. B is constant. So B constant. So the rho is equal to exponential of E minus C C minus E C minus E C minus E by C2 C1 minus E by C2 C2. Here C1 C2 is constant of the ensemble. Constant of ensemble is the E is increasing, rho is decreasing. E is increasing, rho is decrease. The constant E is increasing, rho is decreasing. The two constant C1 is equivalent to C1 is equivalent to gives free energy, gives free energy. E2 free energy, E2 is C2 is equivalent to KT, equivalent to C2 equivalent to KT, whereas here K is the Boltzmann constant. K is Boltzmann constant. The C2 is constant of K KT. Yes, that is KT is equal to KT KT. Here K is Boltzmann constant. Here K is Boltzmann constant of, and T is absolute of the temperature. T is absolute of temperature. That is case 2. Next, third one. This is last and this is last. So both N and E are not constant when both N and E are not constant. N and E are not constant. Are not constant. So rho is equal to exponential of rho is equal to exponential of C1 plus C3, exponential of C1 plus C3 n minus E n minus E by C2. C1 plus C3 n minus E by C2. Exponential of that. So here C1, C2, C1, C2 and C1, C2, C3 are equivalent of C1 comma C2 comma C3 equivalent of is equivalent of which one? Equivalent of minus rho b of minus minus rho b minus rho b comma kt comma kt and mu kt and mu kt and mu, the chemical potential respectively. This is mu value is which one? Ensembles chemical potential. Mu value is chemical potential. Okay, that is the ensemble is the grand canonical, that grand canonical formula this. Okay, so this is represented the case of grand canonical ensemble. Okay, so this is completed and the density of which one? Density of base point in that classical ensemble is a very important 5 marks question is also this one. 10 marks question Lewis theorem is a compulsory question, that one. Today you have to class 15 marks questions compulsory came up your exam. Okay. Lewis theorem 10 marks, ensembles, different type of ensembles, uses of ensemble, and this. Which one? Density of base point in classical ensemble. Compulsory with 15 marks question exam లో ఉంటుంది. ఓకేనా ఈ రోజు క్లాస్ లో. ఓకే, థ్యాంక్ యూ అండి. ఓకే, థ్యాంక్ యూ అండి. Anybody please?